Troubleshoot simulations. In this video, you will investigate common problem areas in Aspen hysys simulations and identify a general methodology for troubleshooting existing hysys cases. In this video, we'll be presented with cases derived from the simulation you have created during previous videos. Errors have been introduced in the cases that prevent them from solving properly. It's left up to you to find these errors and solve the cases. This video includes the following tasks. Task 1. Troubleshoot a refrigerated gas plant. Task 2. Troubleshoot a two-stage compression skid. Task 3. Troubleshoot a gas oil separation train. Task 4a. Troubleshoot a natural gas liquid fractionation train. Task 4b. Troubleshoot a vacuum distillation tower. Task 1. Troubleshoot a refrigerated gas plant. This case is a simple gas plant where the separator temperature is set to meet a dew point temperature specification on the export gas. Open the first attached file with this video, Troubleshoot Starter 1. In this simulation, there are 5 errors distributed among 3 operations. A hint to solve this simulation, you need to think about the purpose of the balance operations and the solving behavior of the adjust operation. Let's start. The first simple check is hysys solver and whether it is active or on hold. As you can see here, it's on hold, switch to active. As you can see, the simulation still hasn't solved. The second step is to check each unit operation and logical operation and whether it is active or deactivated. You can check this from the ignored checkbox. The ignored checkbox tells the hysys whether to ignore the unit operation or the logical operation while solving. Now let's move to the next equipment. It's active. The E1 heat exchanger. As you can see here, it's ignored. And I check the ignored box. As you can see, the simulation has solved except for the hydrocarbon dew point. Based on this observation, the first thing to check is the balance operation. As you can see, it's ignored. But before you uncheck the ignored box, check the balance tau. As you can see, it is set to component mode and heat flow. This setting is incorrect and won't allow for a correct solving of the simulation. Change the balance type to component mode flow and uncheck the ignored box. Now the simulation has solved. This completes the first task. Now to the second task. Task 2. Troubleshoot a two-stage compression skid. This case is a two-stage compression plant in which the liquid knockout streams are recycled upstream. Open the second attached file with this video, Troubleshooting Starter 2. There are errors in 3 places in this simulation that must be removed before simulation will solve. A hint to solve this simulation. Loop systems may be tough to troubleshoot, so first break the recycle outlet stream connections of the mixers, and once the simulation solves, normally you can close the recycle loops again. Attempt to solve the case by adding and deleting a specification as needed. It's a good idea not to delete anything too quickly as you may need the value later on. It's also a good idea to begin at the very beginning of the simulation and work your way through to the end. Start by breaking the recycle connections from the mixers. Back to the Home tab and click Active. As you can see from this message, a consistency error has occurred. This can arise either when two objects calculate differing values for the same variable or one object's calculations are conflicting with existing specification. In general, this means that the simulation is over-specified. Go to the stream to IS separator and delete the defined value for pressure. Click Active again. Here you can see another consistency error related to the molar flow of IS separated liquid stream. Open the IS separated liquid stream. Here there is no defined molar flow, so check the downstream for that stream. Delete the molar flow of the LD1 outstream. Click Active again. Here is another error related to the molar enthalpy LD1 outstream. To clear this error, clear the temperature of the stream. Click Active again. Now the simulation has solved. Reconnect the recycle lines. This concludes the second task of this video. To our third task. Task 3. Troubleshoot a gas oil separation train. This case simulates a high-pressure gas oil separation train. Open the attached simulation file, Troubleshooting Starter 3. In this case, there are 4 problems that prevent the simulation from solving properly. This simulation was built with assay data entered via aspen assay management feature. It's important to verify that the assay was successfully installed in the flowsheet. Start by checking the attachment of petroleum assay to the raw crude stream. As you can see, there is no attached assay. Click Attach Existing and choose Assay 1. Click Active. The simulation still hasn't solved. Check Mix 100 mixer. The mixer is not solved. Check the pressure assignment parameter. It is set to outlet to the lowest inlet. Change the selection to Equalize All. An error has arisen because the simulation is overspecified. As you can see here, the heater heat flow is defined in addition to the cool gas temperature. The two parameters cannot be both defined. Delete the heat flow of the GT cooler. Now the simulation has solved, but it seems that there is an error on the choke valve. There is a pressure increase across the valve, so it's better to check the downstream pressure of the valve. Set the pressure drop across the inlet of high pressure separator back to the default of 0 psi. Now the error has been cleared on the choke valve. This concludes the third task. Now to the next task, 4A. Task 4A, troubleshoot an natural gas liquid fractionation train. This case simulates demethanizer and deethanizer columns in series. Open the attached simulation file, troubleshooting starter 4A. In this case, there are 4 errors that prevent the 2 columns from converging. It's important to remember what a column means in order to solve, such as degrees of freedom, appropriate specification, etc. First, click Active. The 2 columns still haven't solved. Check the monitor page of the demethanizer. As you can see here, the degrees of freedom is 1, meaning that the column needs 1 additional specification in order to solve. Activate the comp fraction specification in the demethanizer column. Please note that you could also activate the overhead product rate specification, but component fraction specs are usually preferred over flow rate specs. As you can see, a consistency error has arisen related to the molar flow of the DC1 overhead stream. Open the property view of the DC1 stream and delete the molar flow. Killing active. This message indicates that column deethanizer has an invalid spec value in spec vent rate. The draw rate must be less than the total feed flow rate. Open the property view of the deethanizer column. Navigate to the design monitor page. Deactivate the vent rate specification in the deethanizer column and also deactivate the use as estimate checkbox as well. The degrees of freedom is 1. So we need 1 additional specification to solve the column. Activate the comp ratio. Now the simulation has solved. This concludes the 4A task. Now to the next task, 4B. Task 4B, troubleshoot a vacuum distillation tower. In this case, there are 3 problems preventing a vacuum distillation column model from solving properly. Apply the best practice for building and specifying column model to track down the 3 errors. Remember the configuration of the vacuum tower from the simulation you previously built. Open the attached hysys simulation file, troubleshooting starter 4B. And again, it's important to remember what a column needs in order to solve, such as degrees of freedom, appropriate specification, etc. Check the monitor tab and find out which specification should be set up. First, click Active. Open the property view of the vacuum tower. Navigate to the design monitor page. Activate the top stage bump around rate specification in the vacuum tower. You could also specify the top stage temperature specification, but it would be useful to pick the parameter for the top stage bump around. Click Run. Although the degrees of freedom is 0, the column hasn't converged. That's because the overhead rate specification value is too high. Insufficient light components are present in the tower to produce that rate, rather than specify the overhead vapor flow rate. Activate temperature specification instead. You need to delete the specified temperature in the back overhead material stream. Back to the property view, the vacuum tower on the monitor page, and check the overhead rate. Active. Now the simulation has converted. This concludes the last task in our video. Thank you for watching.